Alright, in this video we're going to continue some of our introductory information and talk about some of the different ways that we classify matter. Okay, first a couple of definitions that I think most of us are probably pretty familiar with. Atoms are the submicroscopic particles that are the fundamental building blocks of ordinary matter. And of course there are different types of atoms. Each one is represented by a different block in the periodic table, so there are a finite number of atoms. Now when I combine atoms together, we form molecules. And so these molecules are held together by chemical bonds, and they're held together in specific geometries. And the properties of the molecules depends not only on the types of atoms that are connected, but also the shapes into which they are organized. So we have an example of a very simple molecule here. Carbon monoxide is made up when we attach one carbon atom to one oxygen atom. Okay, now I'm sure you all have talked about the different phases of matter in previous science classes, but I did want to highlight what's going on at the molecular level, or the atomic level, when we have solids and liquids and gases. And so solids, of course, occur at the lower end of the temperature scale, and at the submicroscopic level, the atoms and molecules are packed very closely together, and they're fixed in their locations. So they're not free to move around each other, but they do vibrate. And so if we're able to zoom in and look and see what the atoms of a solid look like, we would see that they're packed very tightly together. And of course this isn't an animation, but if we're able to see, the atoms aren't moving all around one another, but they are vibrating in their sort of fixed positions. When we heat up a solid and convert it into a liquid, the atoms and molecules still remain relatively close to one another. The distances that they have are generally a little bit larger than solids, but fairly close to the distances that they had in the solids, but now they're not held in fixed positions. And if we were able to see this animation, the atoms or molecules would be moving around among one another. And then of course, when we heat up a liquid and convert it into a gas, now one of the big differences are the atoms and molecules do have great distances now between them, significantly greater than what we have in liquids and solids. And like liquids, they're able to move around freely inside their container. All right, in addition to phases, another way that we can classify matter is based on its composition. And so we sort of have the heading of all matter at the top here, and then the first question we're going to ask is, do we have variable composition or constant composition? If we have constant composition, then we fall in the category of pure substances. And so if we have constant composition, then if I find a sample of that type of matter anywhere, it's going to have the same properties. And so if I find water on Mars or Earth or in a comet or on Neptune, it's all going to have the same properties and it's all going to have the same composition. If we were to look at water molecules, they always have two hydrogen atoms, which are the yellow or the white atoms, for every one oxygen atom, which is represented by the red spheres. Now the difference between compounds and elements is when we ask, they're all pure substances, but if we ask the question, can we separate it into simpler chemical substances? If the answer is yes, like in the case of water, where I could separate this into hydrogen atoms and oxygen atoms, then we have a compound. Whereas if we can't separate it into simpler substances, then that means we have individual elements, or just one type of element. And so an example of that would be the helium that we pump into blimps. I only have one type of atom, so it's a pure substance. It can't be simplified chemically, and so that's going to be an element. Now, in the case where we have variable composition, we have mixtures, we can further divide mixtures between heterogeneous and homogeneous. And so the difference between these is whether they're uniform throughout or not. So if they are uniform throughout, an example of that in a homogeneous mixture would be tea with sugar in it. Right? So when I look at that tea, I can't see where the boundaries that exist between where there's water and where there's tea and where there's sugar. Right? It's uniform throughout. There are no boundaries. And so that would be an example of a homogeneous mixture. An example of a heterogeneous mixture where it's not uniform throughout would be like wet sand. Right? So I have I can clearly see if I had a beaker of wet sand, I can see that the sand settles to the bottom, and I can then see the barrier there where it's separating the water from the sand. Right? Another example of this would be like oil and vinegar salad dressing. Right? If you let that sit, the oil generally floats to the top, the water and the spices that are soluble in the water floats to the bottom, and then I can see that line dividing the oil and the water. And so that would be another example of a heterogeneous mixture. All right, so these next couple slides just sort of redefine what we talked about on the previous one. So I'll have these posted online so you can look at them there, but I'm not going to go through them in excruciating detail. Pure substances have fixed composition. I can divide those up into elements where I have just a single type of atom, or I can have compounds where I have two or more different atoms that are different elements combined together. And so our mixtures do not have fixed composition, right? I can have more or less sugar in my tea. That's what we mean by variable composition. We have heterogeneous mixtures where there are observable boundaries. The mixture is not uniform. These mixtures, the mixing is not occurring at the atomic or molecular level. In the case of homogeneous mixtures, right, we don't have observable boundaries. They are uniform, so I can't see where the boundaries are between the different components of the mixture. And in the case of homogeneous mixtures, the mixing is occurring at the atomic or molecular level. And another name for homogeneous mixtures is solutions. Most often, when we talk about solutions, we often mean solutions where something is dissolved in a liquid, but it doesn't have to be. The air we're breathing is an example of a homogeneous mixture. Contains mostly nitrogen, about 20% oxygen, and then lower percentages of various other elements and compounds. All right, so I want to finish this video off by just looking at a couple examples. So I'd like you to classify each of the following substances as either being a pure substance or a mixture. And then if it's a pure substance, I want you to tell me whether it's an element or a compound. If it's a mixture, I want you to tell me whether it's heterogeneous or homogeneous. So maybe a good chance, pause the video, see what you come up with, and then compare to my answers. All right, so if we look at distilled water, we talked about water before. That is a compound, and when we say distilled water, that just means pure water. It doesn't have any other substances dissolved in it. And so that would be an example of a pure substance, and it has hydrogen and oxygen. It's not one type of element, so it would be a compound. All right, if we think about wine, so wine contains mostly water. It also has ethanol, which is a different molecule, and then it also has various other molecules that contribute to its different flavors and colors. And so wine is definitely a mixture. I have primarily water and ethanol plus lots of other compounds in there. And I can have higher or lower amounts of ethanol, so it's definitely variable composition. But I can't see the boundaries between the different components of the mixture, and so that would make it a mixture, and it's homogeneous. Right? Vegetable soup, definitely a mixture. Got water, lots of other compounds in there. Right? I can have lots of potatoes, I can have lots of carrots, I can have no carrots. And so definitely variable composition, and we can see the boundaries between them, right? You can dig out a potato or dig out a carrot from the vegetable soup, and so that would be an example of variable composition. So it's a mixture. It is not mixing at the atomic or molecular level, and so it's an example of a heterogeneous mixture. Aluminum foil is composed of 100% aluminum atoms. So it's fixed composition, there's only aluminum, and I only have one type of element. I only have aluminum atoms, so that would be an example of a pure substance and an element. All right, we come to ice. Well, we've already talked about distilled water. Ice is still just water. It's the same compound. It's just now a solid instead of liquid, so it's still going to be a pure substance, and it's still going to be a compound. All right, now seawater, I kind of put this one in here to show that not everything is cut and dried in these examples. I think you could have reasonably said seawater is definitely a mixture, right? We've got water and we have sodium chloride, certainly. So we have two different compounds that are mixed together. I can have higher or lower levels of sodium chloride. And so it's definitely a mixture, but whether it's heterogeneous or homogeneous, right, is a little bit more of a gray area, right? If you got a fairly clean sample of seawater, you might reasonably argue that you can't see any boundaries, right? The salt dissolving in the water is an example of a solution, and so that would be a homogeneous mixture, right? But I think you would also argue if you scooped up and you got some, dirty-ish seawater, right? Maybe you've got some plankton floating in there. You've got some, fish poop. Maybe you have some small fish, right? And so very much in that case, a heterogeneous mixture. So, I think this would be an unfair question to ask on a quiz or something like that. But I wanted to include it to show that, not all of these examples are necessarily simply cut and dried, and there's a lot of gray area that exists here. And so, as long as you can back up your answer, show that you understand it, I think you're in good shape. And then, so I'm going to say mixture, and then I would personally argue, in most seawater, you can see, stuff floating around in there, and so I would argue that it's heterogeneous, but as I explained, you can certainly make a case for it being homogeneous. And then oil and vinegar salad dressing, that was one we already talked about. It's definitely a mixture. We can see the boundaries, and so it's heterogeneous.